We're on lesson 4 of chapter 10, which we're going to interpret stem and leaf plots and histograms. First, we're going to make a stem and leaf plot, then we're going to interpret a stem and leaf plot, then we'll make a histogram. The first thing to learn will be a stem and leaf plot. Well, that's a data display that organizes data based on their digits. And I'm sure you've learned about tens place and ones place before, and that's usually what a stem and leaf plot works with. The stem is usually the tens place, the leaves are the ones place, and they give you a key which to work with here. So if you have a 1 for the stem and a 5 for the leaf, that number equals 15. So for here we have a number 4, this would be the number 12, this is the number 21, that's the number 34. And that's usually the case over here, but in this case actually the stem is the ones place and the leaves are the tenths place after the decimal. When you have 2 for the stem and 3 for the leaf, that'd actually be 2.3, so this would be 4.8. So make sure that you pay attention to the key when you're solving stem and leaf plots. Histograms actually show bar graphs then. They're bar graphs that show the frequency of data at different intervals. So intervals is an important word. Those are different ranges of x values, for example, if you're looking at a graph this way. Let's say the stem values were the x values in a histogram, and the amount of times that they occurred was the y value, the frequency. So from 0 to 0.9, we have 3 times that occurs. From 1 to 1.9, it occurs 4 times. From 2 to 2.9, it occurs twice. And the same idea over here. So for the values of 2.6 to 3, it occurs 6 times. It occurs the most times, clearly. From 3.1 to 3.5, it occurs 3 times. So both of these can show frequency, except a stem and leaf plot shows it a little more clearly. So here we get to make a stem and leaf plot. This is a number of home runs hit by the 20 baseball players with the best single-season batting averages in Major League Baseball since 1900 are listed below. Make a stem and leaf plot of the data. So it looks like the key we're going to be using here is going to be 1 and 4, where the 1 would be the tens place and the 4 would be the ones place. And I see my data ranges from anywhere from 3 all the way up to in the 40s it looks like. So my stems would be 0, 1, 2, 3, and 4. And your book actually suggests that you write this out from least to greatest to make sure you don't miss any numbers. My method without doing that will just be to circle the numbers that are in the zeros place. So that would be these ones that are all under 10. And then cross them off when you're done. So that looks like to be all of them. So if we start at the smallest one, that would be 3. So we have 3 for a leaf. We have 4 for a leaf. Then we have 2 7s. And then we have 2 8s. Using a different color for the tens place then, we have a 14 here, a 19, a 14 again, a 12, and a 19. Oop, and almost forgot this 18. So the lowest one is 12, so we put a 2 here for that because the stem is 1. Cross that off. That's followed by 2 14s, so a 4 and a 4. Then that's followed by the 18, and then we have the 2 19s to finish off that, so a 9 and a 9. Now let's look at the 20s place. So we have 25 here, we have 23 here, and 21. So starting at the lowest, that would be 21. Then a 3 for 23, and a 5 for 25. Now we're left with 30s, so we have 37, 39, 32. So 32 is the lowest here, then 37, and 39. And now we just have 2 40s left to finish up with. So 42 and 41, so 41 is the lowest, followed by 42. So this would be the stem and leaf plot of all the home runs since 1990. And you can really see the value of this. You can really see where the data is spread out instead of just a big list like this, which is sometimes difficult to read. You can really get a figure of how many home runs are typically getting hit. A lot of times it's between 0 and 20, as we see. Now we're going to interpret a stem and leaf plot. And it's actually going to be working with a back-to-back stem and leaf plot, where the stem is in the middle and then the leaves are on both sides for 2 different categories, men and women in this case. So it says the back-to-back stem and leaf plot shows the ages of members of the U.S. men's and women's 2004 Olympic gymnastics teams. Compare the ages of the gymnasts on the 2 teams. So we see that there's a difference here, especially the men. We see the interval is mostly on the 2 here, whereas the women have the biggest interval on the 1. So that would tell me if we follow our key here, that 1 and 6 is going to be 16 years old, and 1 and 8 is 18. So we have a couple 16-year-olds and a couple 18-year-olds, whereas the men have mostly 20-year-olds on their team. Women have a couple 20-year-olds, but mostly teenagers. So if we're going to compare these two, it doesn't take too much work. You're just going to say that the men are typically older. And we're not going to say they're always older because we have some women that are older than men, but in general, you'll say the men are older. Now we can make a histogram. And remember what a histogram was? That measures the frequency of different intervals. So it says the prices in dollars of sandwiches at a restaurant are listed below. Make a histogram of the data. So first we actually need to figure out what our intervals are. First it's good to look at the range of our data, where I see the lowest is 4, and the highest would be 5.95. So if we're looking to make 4 intervals over a distance of about 2, we can divide that by 4 and find an interval that would work. So 2 divided by 4 would be 1/2. So let's go with 0.5 as our intervals. So we have an interval of 4 to $4.49. Then we'd have $4.50 to $4.99. Then we'd start at $5 and go all the way to $5.49. Then we'll go to $5.50 and go all the way to $5.99. So if we have $4 here, that's going to be in this interval. This is going to be in this interval as well. 4.25 is also in this first interval. 4.5 is going to be in this interval. 4.75 belongs here. 4.25 is back in this one. 5.95 is in this one because it's below 5.99. 5.5 also belongs here. 5.5 belongs here. And 5.75 belongs here. So now we actually can create this table. So our first bar graph is going to be 4 to 4.99. So that happens 4 times. That means this bar graph needs to go all the way to the top at 4. And that's where we'll leave that. Our next interval is 4.5 to 4.99. So 4.5 to 4.99. As we make our graph for that, that goes all the way up to 2. Running out of room here, so let's try taking a little bit less space. We have 5 to 5.49, so we'll do this a little bit diagonally. 5 to 5.49. And you see that that didn't actually have any sandwiches in that price range, so we're not going to fill out anything at all. Then our last interval is 5.5 to 5.99. So 5.5 to 5.99. And that had 4 sandwiches in that price range. So as we draw our bar graph, that goes all the way to the 4. So this would be our histogram with 2 intervals of sandwich prices at the 4 frequency and one happening only 2 times. So this is what created our bar graph.